arc measure is just an angle pulled from our central angle. Arc length, we're going to be putting like inches, meters, feet behind it, like actually how long is that arc, the curved line. Okay? Mostly formulas today, and these formulas are on the bottom of that gold sheet that you will get for quizzes and tests. But in here. Define arc length, so how long an arc is. I know yours is hard to tell what's like highlighted there, but all you're gonna do is find the measure of the arc, and remember that's the same as our angle from our central angle. So you're gonna take your angle measure divided by 360 times either 2 pi r or pi d. And do you guys remember what these 2 pi r and pi d formulas stand for?
Radius and diameter.
Radius and diameter, but when I find just 2 pi r, what is that? Yeah, my circumference. So all you're doing is taking your angle divided by 360 times your circumference. Whether you have your radius, you're going to use 2 pi r. If you have your diameter, you're going to use pi times d. Okay? And then make sure we label these as well. So if I look here, first off, like I said, I know yours is really hard to find. XY is the arc we're looking for. So what would be the angle measure associated with XY? 90. 90, so we're pulling out this guy, 90. So I take 90 divided by 360. And then do I have a radius or diameter? A diameter. So I'm going to use 16 times pi. We're going to leave answers in terms of pi, so that means leave your pi there. If I take and reduce 90 divided by 360, what fraction do I have? 1/4. So 1/4 times 16 pi. And I simplify that. What is 16 divided by 4? 4. So my arc length is going to be 4 pi inches. In B, we're finding this guy right here. Like I said, I know it's really hard to see on yours, but. So what would be the angle measure associated with that arc?
120.
How'd you get it?
180 minus 60.
Good. We know this guy is 180. Subtract out this 60 that's labeled. So this angle is 120. So take 120 divided by our 360. Radius or diameter? Diameter. So 18 pi. Diameter times pi. Reduce my fraction, 120 over 360. 1/3. So I have 1/3 of 18 pi. So what is 18 divided by 3?
6.
So I have 6 pi, and what's the middle label? This one we're finding our guy that's almost all the way around. Ooh, I tried to trace it. What's my measure associated with that arc? 240. So take 240 over my whole measure, 360. Radius or diameter? Radius. So this time I have 2 pi times 15. If I reduce 240 over 360, what's that fraction? 2/3. What's 2 times 15? 30. So 2/3 of 30 pi. What's 2 times 30?
60.
What's 60 divided by 3? 20. So I have 20 pi. Label it. Good. Okay. Questions there? Okay. Cross off this. A sector of a circle, finding the area of it. So what we're doing is finding the area of this shaded part, okay? So not just the arc measure or the arc length, but the entire area of this. How did we label area before?
Inches squared.
Inches squared, meters squared, something squared, okay? Do you guys remember the area of a circular circle formula?
Is that like circumference?
Your area. No? No, you're close. Area of a circle is pi r squared. So all you're doing is taking that area of a circle times the fraction of the circle that it takes up. Okay, so same thing as before, that arc measure divided by 360. So it'll tell us how much of the circle we're taking times your area of a circle, pi r squared. Where r obviously stands for.
Are we gonna keep it in pi?
Say that again, bud?
Are we gonna keep it in pi?
Yeah, it says leave your answers in terms of pi.
Okay.
Okay. So if I look at this section right here, what measure is associated with that? So I'm gonna take 72 over 360 times pi. What is my radius? 15, so pi times 15 squared. Good, 1/5. And then what is 15 squared? 225 pi. So then take 225 divided by 5, and we get 45 pi. And then this time when I label, I'm going to do centimeters squared, because we were talking about area. It's not hard? Good. Formulas. This guy we're finding most of the arc. How can I find what degree measure that is?
360 minus
360 minus 40. So 360 minus 40, I get what? Who said it?
320.
320. So take 320 divided by that 360.
Wait, why did you do the 360 minus 40?
Because we want to find this measure. And I know circles have 360. So I want all of the 360 except for that 40 degree part. I need pi r squared. What am I using for r?
8.
8. 16 is the entire diameter. To find radius, I need to half it. Does that make sense? Okay. So pi times 8 squared. What is 320 divided by 360? 8 over 9, which is not nice. That's okay. And then 8 squared.
64.
64. So take 64 times 8. What do we get?
512.
512. Take 512 divided by 9. Do we get a nice number? No. So we are going to leave this as 512 over 9 pi label centimeters squared. If you want to, you can change this into, I think it's like 56 and 7/9, something like that. I don't even know. You can do that if you want to. I just think that's easier. Okay, here is the only kind of tricky part about this part of 10, 16, 7. When you want to find only a segment, so not an entire sector, not just an arc length. You want to find just this little shaded part. We gotta find two things. So you see how this is not an entire sector? Or see that how it doesn't stem from the middle? We're going to find the area of the sector, so like if it was coming from the middle, and you're going to subtract out your area of your triangle, and that's what you're going to be left with, is that little shaded part that you want. Okay, so start with area of sector. What degree measurement am I gonna use?
60.
60. So I got that 60 over 360 times, now talking area, I got that pi r squared. So what am I going to use for r?
18.
18. So I got pi 18 squared. Fraction of 60 over 360? 1/6. What is 18 squared?
324.
320 what? 4. Yeah. To reduce, what should I do? Divided by 6. Good. And we get how much pi? 54 pi. Okay. So that's if I found this entire thing. Okay, that's my sector. Okay, I have to subtract out the triangle portion. So that I'm left with just that very little small chunk. Okay, so I gotta find my area of the triangle. What's the formula for area of a triangle?
1/2.
Half base height. Good. Half. What am I gonna use for my base of this triangle? 18. Here's the tricky part. I'm gonna make a bigger triangle. Notice it says this angle 60. How can I find my height? 30, 60, 90. What is this guy?
9 squared.
Hold on. This guy is
9.
just 9. So my height is
9 squared is 3.
9 squared to 3. How should I write this? Questions there? Okay. So half of 18 is 9. 9 times 9 is? So I have 81 squared root of 3. So to find this very small guy, I'm going to take 54 pi minus that 81 squared root of 3. Here's how I would type into a calculator. It does say round to the nearest 10. So I would put parentheses around 54 pi minus parentheses 81 squared root of 3, just in case, because some calculators don't like when you multiply and subtract. You should get about 29.3. Let me know if you don't get that. You took 81 times square root of 3.
Oh.
So 54 times pi minus 81 times square root of 3.
Let me get
You didn't get that?
I think that's
54 times 3.14. Oh, you multiplied. And then all you want to subtract.
Okay.
Then you good. Okay. Anybody else know?
What did you say?
29.3 about.
Yeah.
Okay. Alright, one more. If you don't like it, don't use it for sorry. Yeah. Some of them are done, some of them are done. Alright, so first thing I gotta find again is what? My sector, yep, area of sector. And how am I gonna do that?
9
90 divided by 360 times what? Pi 4 squared foot. My fraction 90 over 260 is how much? A fourth. What is 4 squared?
16.
16. So how much pi?
4 pi.
4 pi. What else do I gotta do? Find area of triangle. This one is much nicer. I got half. What's my base? 4. What's my height?
4.
4. Remember, base and height have to make a right angle, which is what you have. So these are both radiuses. So if this is 4, this has to be 4. So your base is 4, height is 4. So what's the area of my triangle?
8.
8. So how am I going to find just this little very tiny section? Subtract them 4 pi minus 8, however that works in your calculator. And let me know what you get.
4.56.
So 4.6. And then my label.
Meter squared.
Questions there? None?